Hello everyone, Professor Vaibhav Shah here. Hope you have checked my previous lecture, lecture 1, which is containing basics of scales, types of scales, representative fraction or RF, and way to solve examples. In today's lecture, lecture number 2, we will be solving some more example based on concept learned from previous session. If you like my content and teaching style, then share it with your friends and do not forget to like and subscribe to show your love and support. So let us start. So now, first we'll be using these following formulas for calculation in this topic. So once again, first formula, representative factor, RF. RF equal to dimension of drawing upon dimension of an object. If your dimension is given in the terms of length, so you will be writing length of drawing upon actual length. If your dimension is given in form of area, so you'll be taking under root of area of drawing upon actual area. And if your dimension is given in the form of volume, so you'll be taking cube root of volume as per the drawing upon actual volume. So this is your first equation. You have to memorize this equation. Next, we have one more equation, length of scale, which is equal to RF into maximum length to be measured. So here RF is you can get from this previous equation, and maximum length to be measured would be always given in your data. So you have to read from the data and you have to just put this value of maximum length. You will be having this length of scale. You will be using this length to draw our actual scale in our drawing sheet. So now let us begin. So now we have to remember one more thing before going ahead. Unit conversion table. This is the most important table. You have to remember this table. So once again, look at this table. So you'll be having number of unit conversions. So this is the table. I believe that most of the examples of your examination will always come from this table. So we'll once again go through this table. 1000 millimeters is equal to 1 meter. 100 centimeters is equal to 1 meter. 10 decimeter is equal to 1 meter. 1 decameter is equal to 10 meters. 1 hectometer is equal to 100 meters. 1 kilometer is equal to 1000 meters. 1.609 kilometers is equal to 1 mile. 1 yard is equal to 3 feet. 1 foot is equal to 12 inches. 1 inch is equal to 2.54 centimeters. 1 nautical mile is equal to 1852 meters. 1 meter is equal to 1.0936 yards. It seems too difficult to memorize this table, right? So now I will give you one easiest way to memorize this table. So we'll be using this staircase. So let us see this staircase. So you can convert units from kilometers, hectometers, decameters, meters, decimeters, centimeters up to millimeters. So you can convert your any units from kilometers to millimeters by this staircase. So now if we go up in this staircase, so we have to divide it by 10 meters. And if we go down in this staircase, we have to simply multiply unit by 10. So now let us suppose we have to convert 1 kilometer into meter. So what is the procedure? How we'll use this staircase? So now, right now we are at here. As you can see, look at the cat. So cat is sitting at kilo. That means you are at the kilometers unit. Now, you have to reach this base unit meters because you have to convert kilometers into meters. So cat has to step down by 3 steps, 1, 2 and 3 to reach this shoe which is on the base unit. So we will get down by 3 steps, and if we are coming down or we are going down by 3 steps, then we will be here multiplying 10 for each of the steps. So we are going down by 3 steps. That means we'll be multiplying 1 kilometer by 3 steps, which is 10, 10 and 10. So we are having each step of 10. So we'll be multiplying it by 10, 10 and 10. So we'll be having 1 kilometer is equal to 1000 meter. You can try and experiment with your another units and you can get a better idea of this staircase procedure. But I will say you have to remember this table. So write down somewhere, you can remember it and you can use it afterwards. So now let us move to directly the examples. So example number 1. In a map, 36-kilometer distance is shown by a line of 45 centimeter. Calculate the RF and construct a plane scale to read kilometers and hectometers. For maximum of 12 kilometers, show a distance of 8.3 kilometers on it. So first let us analyze this data. So in map you are having one scale. So 36 kilometer is equal to 45 centimeters is your scale given. So we will convert this scale into your required RF. Second, construct a plane scale to read kilometers and hectometers. So your scale should specify kilometers and hectometers on it as a units. Now, for maximum of 12 kilometers, so your scale should measure maximum of 12 kilometers. And you will show afterwards on that scale distance of 8.3 kilometers. So you will specify or indicate 8.3 kilometers on your scale drawn. So now let us first calculate the RF. So RF would be 45 centimeters long line. So RF is the ratio of your dimension of your object in drawing to the actual dimension of an object. So this is your dimension of the object in drawing, which is 45 centimeter, and your actual dimension on the map is 36 kilometers. So we'll be dividing 45 centimeter by 36 kilometer. Now second step is we'll be converting the units into lowest possible units. So our lowest possible unit is centimeter. So we'll be converting anyhow kilometer into centimeter. So we know that we have to convert this kilometer, right? So 1 kilometer is equal to 1000 meters. So we'll specify kilometer by 1000 meters. Now 1 meter is equal to 100 centimeter. That means we'll specify this meter by 100. So our final conversion would be 36 into 1000 meter. In that meter, we have converted that meter into 100 centimeter. So that means 36 into 1000 into 100, which is our final conversion, and which will give us answer in centimeters. After that, centimeter both get cut, and you will have your answer as 1 by 80,000. So this is your RF. Next, actual length of scale. So RF into maximum distance. So here RF is 1 by 80,000. As you can see, we have got this data 1 by 80,000. Now maximum distance. So we have this maximum distance from our data, which is 12 kilometers. So let us put this 12 kilometers. Once again, we'll be converting this kilometers into centimeter. So now we'll be using 1 by 80,000 into 1 kilometer is equal to 1000 meters. So we have converted 1000 meters, and 1 meter is equal to 100 centimeters. So we have converted this meter into 100 centimeters. So that means our final answer would be 12 into 1000 into 100, which is now final data converted into centimeters. After solving this equation, you will get your final answer as 15 centimeters. So your actual length of scale, which we will draw next, is 15 centimeters. So now let us draw one line of 15 centimeter length. So this is your line of 15 centimeter length. Now after that, we have to divide this line into suitable number of equal divisions. Now what number of division we should divide this line? So always you have to focus on maximum distance for this division purpose. So here the maximum distance we have to measure is 12 kilometers. So we have to look for the significant digit. So your significant digit is 12. So it is saying that your answer should be divided by 12 divisions. So now we have 15 centimeter line, and we got this answer from maximum length 12 as our significant digit. So now we must compulsorily divide our line into 12 equal parts. So let us divide this line into 12 number of equal parts. So I will start dividing them into 12 equal parts. So let us divide this 15 centimeter line into 12 equal parts. After that, we'll be putting 0 at the end of this first division. So let us put 0 here. So I have put this 0. After putting this 0 on the rightward direction, we have to specify the primary unit. So we have to measure the scale of 12 kilometers. So we have just omitted this first part. So we write down the number for this kilometers: 1 kilometer, 2 kilometer, 3 kilometer, 4, 5, 6, 7, 8, 9, 10, 11. Always remember that the last digit here comes would be one digit less than your actual maximum length, because we have omitted one division here. So it will be always one digit less. So here is 11. Now from your left of the 0 division, you will be dividing this portion into 10 equal parts. So let us subdivide this first portion into 10 equal parts. Now we are dealing with the kilometers and hectometers. So obviously kilometer is a bigger unit as compared to your hectometers. So kilometers must be your primary unit and hectometers must be your secondary unit. So you will specify on this right hand side primary unit scale kilometers here, and this would be definitely a secondary unit which would be your hectometers. So you must know that 1 kilometers is equal to 10 hectometers. That's why we are dividing this portion into 10 number of equal parts, because 1 kilometer, this is 1 kilometer, this is also 1 kilometer. So now we'll be dividing this 1 kilometer into 10 equal parts showing the hectometers. So now let us specify 0, 5 and 10. After that, we'll be drawing one vertical line. So always remember, we'll be drawing this vertical line either of 5 mm or 10 mm, but I will always recommend 10 mm for good representation. So this is your vertical line, and you will draw one rectangle and you will finish this rectangle. This is nothing but your scale. So after drawing your scale, you will specify the units. So let us start specifying the units. So now we will always specify these units. So always try to specify your hectometers just below your secondary unit or your subdivision unit, because it is a secondary unit. Kilometers always specify between your midpoints. So 0 to 11. So midpoint would be 5.5. So we will try to specify this kilometer just at the midpoint of this primary scale, because it is your primary unit. And after that, try to represent your RF always on the right hand side of your scale, which is the rightmost side of your scale. So this is your scale ready. Now what we have to do is, now we have to show a distance of 8.3 kilometers on it. 8.3 kilometers. So what we'll do is, we'll measure 8.3 kilometers means 8, which is your primary unit, and after decimal point we'll specify your second unit. So we'll measure 8 from your primary unit and 3, which is after decimal point, from your second unit. So we'll measure 8, this primary unit, from this primary scale, and after point, a decimal point, we are having this 3.3. We'll try to measure this 0.3 after this 0 point on the left side on your secondary scale. So let us try to measure this. So we'll start with 8.3. So first let us measure 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So you will draw one vertical line. So it will specify 8 meters here. And to measure this digit 3 after this decimal point, so we'll try to measure it from here, from the left hand side of your 0. So let us start 0, 1, 2 and 3. So you will draw one vertical line from here, and between these two vertical lines you will specify your units. So let us draw. So this is your 8 kilometers, 3 hectometers. So it is, we have measured this 8 kilometers here and 3 hectometers, 0, 1, 2, 3, and you have to just draw this line. So your example is over. Very easy. So let us see one more example. Now, construct a scale of 1:4 to show centimeters and long enough to measure up to 5 decimeters. Indicate 3.7 decimeter on the scale. So we have to construct one scale. RF is given 1:4. We have to show centimeters on the scale. Obviously, your primary unit is centimeters, and long enough to measure 5 decimeters. So we have to measure 5 decimeters. So now indicate 3.7 decimeter on the scale. So now let us start with the RF. So RF is given as 1/4. Maximum distance which is measured is 5 decimeters. So we have actual length of scale is equal to RF into maximum distance. So 1/4 into 5 decimeter. Now decimeter, it is maximum distance which is 5 decimeters. So once again, we have to remember our unit conversion table, and as we know, 1 decimeter is equal to 10 centimeters. So we have to convert this decimeter into centimeter. So now we'll replacing this decimeter by 10 centimeters. So we have replaced by 10 centimeters. So we'll be having this final answer as 12.5 centimeters. So now let us start drawing this problem. So we'll first draw one line, which is a line of 12.5 centimeter. Now we'll divide this line into suitable number of parts. So now how many number of parts will be dividing this line? So you have to look for the maximum measurement. So maximum measurement is 5 decimeters. That means our significant digit is 5. So we'll be dividing compulsory this line into 5 equal parts. So let us divide this line into 5 equal parts. So 1, 2, 3, 4 and 5. Now it is a time to give the numbering. So we'll start from your first division end point. So we'll start from 0 here. So 0, 1, 2, 3 and 4. Now it is actually a 5 decimeter, but we are starting from the end of the first division. So it will always show one digit less than your actual maximum length, which is your 5 decimeter. It is showing 4 decimeters here. Now this is your primary scale. So we'll be specifying decimeters here, because decimeter is a higher quantity as compared to centimeters. So in this case, decimeter would be your primary unit. Now this is specifying 1 decimeter, this is also specifying 1 decimeter. So if we divide 1 decimeter into 10 equal parts, it will give us a secondary subunit as a centimeter. So let us divide this first portion into 10 equal parts by our previous example, similar way by previous example. So we'll be dividing this by 10 equal parts. Now let us suppose this is the smallest division and you can't divide it by 10 equal parts by any particular division. So you will use this triangle method to divide this particular portion into 10 equal parts. If you don't know how to use this triangle method, then you refer my video on basic prerequisite to engineering graphics and you will get to know how to divide this line into 10 number of equal parts if we have no particular parts for these divisions. Now after dividing this line, we'll be specifying 0, 5 and 10 and we'll specify units under this. This is secondary unit centimeter, this is primary unit decimeters, and this is we'll specify RF on the right hand side, which is 1/4. Now here we have to indicate 3.7 decimeter on the scale. So now 3.7 decimeters means 3 is your primary unit, and after your decimal point you are having 7 as your secondary unit. So we'll be using 3 on this primary unit to measure 3, and 7 for 7 we'll be using this secondary scale. So let us first identify 3. So 0, 1, 2 and 3. So this will identify, draw one vertical, and this will identify 3 decimeters. Now we have to indicate this 0.7. So after this point, the digit will be measuring from the secondary unit. So let us start 0, 1, 2, 3, 4, 5, 6 and 7. From 7th division, draw one vertical line. So you'll be having these as 3.7 decimeter. So this was also very simple. So this was the end of your problem number 2. Let us move ahead. So now remember, to construct the scale, the data required is first the RF of the scale, second the units which it has to represent like millimeters, centimeters or meters or kilometers in MKS, or inches or feet or yards or miles in FPS. Number 3, the maximum length which it should measure. If the maximum length is not given, some suitable length can be assumed. Number 4, actual length of the scale to be constructed on the drawing sheet, which can be found out by this equation. Actual length is equal to RF into maximum length to be measured by the scale. So this is all from my side. Do not forget to share with your friends and like and subscribe to show your love and support. Keep learning, stay connected, and if you have any doubts or queries, feel free to comment below. Bye-bye.